by Dr. James. So hopefully Dr. Leon Lobo is on the system. Dr. Lobo?
One moment.
Hi.
Can you hear me?
Yeah, I can. Perfect. It's all working. Brilliant, brilliant. Very quick introduction for you then, just for the benefit of those listening. But you had a bit of an introduction anyway from Bryn previously. So head of the National Timing Centre. I've got to admit, when I read through your bio, there are a couple of things in there that really struck me as the role of the Timing Centre, which I'm sure you'll come into. But it was really focusing on not just technology, but how do we make sure we maintain and sustain the skills that are required to sort of keep this capability for the future as well from a national perspective. I was also struck as well by the NPL time, sorry, which was focused on some of those really key areas and services that are reliant on time. The recognition, I think, nationally, of the need to sustain those for the good of the UK, which I thought was really encouraging. So I really look forward to listening to what you have to say, because it sounds like some really interesting and really important things taking place at the National Timing Centre. So, Dr. Lobo.
Excellent. Can you see my screen, Nick?
Yeah, we can.
Excellent, brilliant. Well, so I'm Leon Lobo, head of the National Timing Centre at the National Physical Laboratory. So just give you some background to the National Physical Laboratory for those who haven't come across this. We're the National Measurement Institute in the UK. So we provide effectively the UK with traceability to the SI. So the second, the meter, the kilogram, etc. And in this instance, we manage what is the national timescale, UDC NPL, but we also provide the UK with the realization of the SI second. So our cesium fountains effectively provide the UK with what is the duration in time that is a second. And we do that to the 16th decimal place. But that's another thing. So today I want to talk about atomic clock developments. Bryn alluded to a lot of those. In addition to the managing the timescale, we are developing the next generation of clocks, which will effectively form the redefinition of the second as we move forward, but also generating some miniature clocks for implementation in devices, basically. But the primary discussion really today is we've heard a lot about GNSS, about the threat, the vulnerability, and some of the solutions that are being put in place toward that future PNT resilience. And we all know PNT as position, navigation, and timing. The timing element specifically, though, is quite essentially a utility that really needs a lot of unpicking when you look across critical national infrastructure. Now, in our new normal, I mean, unfortunately, this event moved from a face-to-face to a entirely digital platform with all the challenges as Bryn faced earlier regarding it, but our increasing dependence on our digital infrastructure is only going to get even more significant as we come out of this. And our digital infrastructure around us is very, very rapidly evolving to support that. That in itself is something that we really need to be cognizant of in order to ensure that we can protect it so that we can continue to operate in this way. With that digital landscape evolving, our threat landscape is evolving very rapidly as well. I mean, we've heard a lot about the jamming, the spoofing, the space weather, and Bryn talked about anti-satellite threat as well. But one of the key things that really needs to be looked into much greater detail is our interdependency across all these different areas on that underpinning that is time. And some of the applications that we know now, whether it's the telecom sector, energy, broadcasts, finance, etc., have very defined implementations for that requirement. However, there's a whole suite of emerging applications that are coming, whether it is autonomous vehicles, smart infrastructure, wide area IoT, sensor networks, and as I talked about, our digital way of working as it stands, how that will expand. And there's significant efforts globally. I mean, we talked about the exec order being signed by Trump in the States. There's the activity in the UK, but there's activity across the globe in order to put in place alternative position navigation and timing solutions in order to support what is essentially our current source of time, which is based around GNSS. As I said, this is going to be particularly important moving forward. Now, we've got a whole host of CNI sectors which are very, very interdependent and reliant on position navigation and timing, whether it is, as I said, network synchronization for the telecoms or broadcast networks, phase synchronization of the power grid, time stamping in the finance sector, but all of these are also very interdependent. And being able to understand how that operates from the position navigation and time front is one element, but that timing and unpicking that is quite significant. Now, the Blackett, can't go through a presentation without mentioning the Blackett report. One of the key things actually that wasn't mentioned so far is the dependency across critical national infrastructure sectors on GNSS was raised within the Blackett report. But what was more important is that there's a lack of awareness of that dependency. So a lot of work that's been done, whether it's within government or within industry, is to start to really delve deep into operational capability and to really understand what the dependency is on GNSS, because almost always it can be a hidden element within infrastructures. Because as Brendan raised, it is easy. It's a freely accessible signal. It falls like rain. You've got low swap receivers, so it's easier to implement a new receiver than necessarily tap into the primary systems. And the receivers are very cheap to implement. All of that sort of makes it incredibly difficult to really unpick that dependency. The London Economics report also was raised previously, so I won't go into that, but that 1 billion a day is quite a significant figure to consider should we lose GNSS. Now, the invisible utility that is time, you have, from a position and navigation perspective, you almost always understand the application base. So whether in the civilian space, for example, you have GNSS on your phones for navigation or in your car. For a logistics firm, you have that capability. But where timing is implemented, it is almost in the background. It's almost always in the background. And from a threat perspective, when you come to look at protecting infrastructures, mitigating against those threats and vulnerabilities, time almost always falls into the gap between the cyber and the physical. Even though there is a significant dependency in order to operate infrastructures across critical national infrastructure. What we are trying to do with the National Timing Center is essentially start to consider what ought to be done for the future in order to protect and secure our capabilities across the board by, one, securing what is the national timescale as it stands, but being able to provide assured capability, engaging with government and industry to provide those services. Now, one of the things that was raised previously was, the whole element of, we talk about accuracy. There's accuracy, there's availability, there's integrity, there's continuity. One of the elements that's almost never considered is traceability. So when you talk about having an accurate signal, you only know you have that accurate signal if you can trace that all the way back to what is a common reference. And in this case, from a time perspective, it is that global reference that is UTC. And I'll talk a little bit about that. But what we're trying to do here is basically secure what is the national timescale, but ensure that we can disseminate that in a resilient way to support what is going to be a system of systems approach to resilient PNT, whether it is GNSS and a UK capability, or whether it is an ELO-RAN system, so terrestrial broadcast, or whether it's about delivering time over terrestrial networks. It is about providing an alternative capability that is monitored and can be traced back to the reference in order to provide that assurance piece. So what is time? I mean, we talk about GNSS providing time. We're going to talk about the National Timing Center. So where does it come from? So the International Timescale, UTC, or Coordinated Universal Time, is essentially generated by about 80 national measurement institutes like NPL, like the US Naval Observatory, like NIST in the US, all contributing data from their clocks. And these are high-end cesium clocks, hydrogen masers, cesium fountains, into the Bureau of Weights and Measures, the BIPM, which is effectively our umbrella organization for all the national labs globally. And what is done there, so the data is sent in on a monthly basis. Well, in fact, it's much quicker than that. But essentially, you create a weighted average that is free atomic time. Now that essentially becomes International Atomic Time, or TAI, which some of you may know, based on this data from the cesium fountains, which lock down that duration in time that is a second within that time scale. That only becomes UTC based on what the Earth is doing at the time. So the Earth wobbles, it's slowing down, and when you compare solar time to atomic time is much more stable. And so as soon as we get a divergence between what is atomic time and solar time, we need to implement what some of you know as the leap second. And it's only then that essentially that weighted average becomes what is known as UTC. Now, the important thing really to consider here is that UTC, through that process, that calculation, is a paper timescale. It is not a real-time timescale. The real-time realizations are from labs like NPL, like the US Naval Observatory and NIST, where we actually manage national timescales and disseminate those. So to give you an idea, it's a GNSS really from a time perspective is a dissemination solution delivering UTC USNO, which is its source. Similarly, within the UK, NPL manages the timescale, and that's useless to anyone unless we disseminate that. And we do that over RF broadcasts, over the internet, we even have machine-to-machine dial-up systems still in operation, some of the legacy systems out there, as well as very, very dedicated assured capability where we are delivering time over fiber to, for example, the finance sector in the City of London. That in itself is a very interesting requirement within the European finance market. And this is the case in the US as well, where it's not just having the right time is required at the timestamp, but also being able to demonstrate traceability to the reference that is UTC. And in order to be able to do that, you need to not just get a good source, but you need to manage your systems all the way from the source to the application layer and be able to demonstrate what the uncertainty propagation is and how what is actually achieved at the timestamp is within tolerance as per the regulation. And that's where I'd say in a lot of the regulated implementations for time it's going to move towards. It's not just about having the time, it's about demonstrating that level of traceability as per the application requirements. So what are we doing about it in the UK? Not just about managing the timescale, but also delivering that and securing it. So Brendan raised this. So the National Timing Center program essentially is an NPL-led program. We've got government partners delivering this. And it's about creating that trusted fabric around time for the UK, such that you have essentially a complement to what is GNSS. An entirely independent complement, that is. So you can not only leverage this and have an assured capability for the future, but also use that to monitor what these signals in space are doing in order to make sure that the rest of your infrastructure is operating as it should be. And across the board, I mean, when you look at some of the emerging application base, there's a lot of work being done into the functional requirements, and many of them are safety critical. When you look at autonomous vehicles, smart cities, etc. But being able to secure this underpinning piece that is time is going to be significantly important for the future. And in order for those applications to be widely adopted. So the program as it stands is a 5-year program, which we put into the UKRI, so under the Department of Base, into their Strategic Priorities Fund with our government partners, in order to essentially start to protect that time capability in the UK. And that's, as I say, it's going to be really important for our wider infrastructure moving forward. So we've got 3 primary objectives around the National Timing Center. The first one is around resilience. And I guess over the duration of this conference, there'll be a lot of discussion around that resilience piece. And what we're doing there is creating a distributed capability that will allow us to operate in the event that any one site went down. But in addition to that, and as almost an umbrella piece for the UK, we are also driving and stimulating what will become a UK supply chain for timing solutions. And at the same time, also assessing and addressing the skills gap in industry, in government, in academia around the timing piece. Not just around how you use the time, but how you get the time, how you monitor it, how you manage it, and how you secure it. So it's quite a wide-ranging program, not just an infrastructural aspect, but also around engaging industry, providing funding to innovate, and also addressing the skills gap. On what we class as a resilient, enhanced timescale infrastructure, we are securing the code that is currently the national timescale on a single site. The key element here around that goal of resilience is about multimodality. So it's not about using multiple GNSS solutions that all have the same failure mode. It is about connecting up these sites using multiple orthogonal dissemination systems. So we'll be leveraging fiber in the ground, RF, satellite signals, so SATCOMs for two-way satellite time and frequency transfer, as well as GNSS. So we'll be leveraging GNSS as well. And in addition, each of these sites will have the very, very high-end clocks from a UDC management capability in itself. So these will be fully meshed, all reporting to UDC formulation, so that the UK will always have a UDC capability should any site go down. Now, of course, as I mentioned previously, there's no point managing a timescale if you don't deliver that to the nation. And part of the innovation piece that we've got is about essentially working with industry on a sector-by-sector basis, putting in place dissemination nodes. So these nodes effectively won't be contributing to UDC formulation, but will essentially access the time and frequency references from what is RETC in order to start to shape what these nodes look like. So there'll be R&D capabilities for the duration of the program. shape these nodes for the sector. So everything from the holdover requirements from the dissemination to the nodes, dissemination from the nodes, the interfaces, the management, the monitoring, the control, in order to structure it such that beyond the program, we can scale up and deliver these nodes wherever they're required on a sector requirement basis. And that last leg effectively to the end users, we are looking at engaging with industry to start to develop and provide those assured services, where you've got those metrics, and it's all about those metrics, about traceability, about accuracy, about availability, integrity, continuity, etc. And being able to demonstrate those to the end user. And of course, different applications will have different, you could say, balances to be struck between those metrics. So as I think some of the earlier speakers raised, it's not all about accuracy. It can be about availability or being able to know that you will have the time in the next hour, in the next day, in the next week, as opposed to just having the highest accuracy signals. But there's also the opportunity for the future, because we are delivering directly from the national capability and that national UTC source, to be able to deliver signals that are better than GNSS. And the question is, what could you do with signals better than GNSS? That in itself is something that could generate some disruptive applications in the future. So on the skills perspective, we've already carried out some skills surveys with industry to really understand what their pinch points are. And in almost all cases, the responses have been, there's an absolute need for addressing that gap, because in almost all cases, they cannot recruit the skills necessary for their capability. They've got to reskill and upskill personnel in order to suit their requirements. And so to that extent, what we are doing at the moment is generating what is going to be a training blueprint for the UK in order to generate new training courses, degree level modules, PhD studentships, apprenticeships, secondments, in order to really create a powerhouse within the UK around time and frequency, dissemination, synchronization, and the like. And really, we are engaging industry at this stage, not just to tell them what's coming, but to help to get them engaged in order to shape the outcomes. So this is really an open call for everyone on this conference to come and engage, tell us your requirements, tell us what you need and how you need it, and what your challenges of the future are going to be in order for us to shape that. And that's primarily it for me. I'm open to questions now. Over to you, Nick.
Thanks, Lou. I'm just waiting for video to start. Soon. I have to say, just a quick comment. I found that fascinating. So thank you very much. I would say we've kind of focused a lot about dissemination means for some of these signals, and timing signals. And there's been lots of talk about integrity and assurance. But I've got to admit, in my mind, most of that was more about the medium for transmission as opposed to actually the generation of the signal itself. And I'd never really thought about it quite the way you sort of presented there. And so I found that actually quite fascinating, especially when you start thinking about, life critical services and, liabilities that sit within the use of timing signals, and how do you make sure that everyone's using the same accredited, assured, accountable timing signal. I mean, that seems like quite a challenge. Maybe I'm overthinking it, but that seems like quite a challenge if we're going to have potentially lots of forms of generation of signals. How do you make sure everyone's working to the same standard, be it in the commercial sector or even in the government sector? And I think that actually links back to one of the questions that was asked of Brim, which I'm going to raise now, and hopefully Peter raised it. I won't butcher this, but he was probably asking about if multiple sites are having to use timing signals, potentially in this case, provided by an augmented GNSS system. How do you make sure that everyone is going back to that same source And I guess that wouldn't have to be augmentation of GNSS, it could be everything. I mean, I'd be interested to know, is it a technical thing? Is it a legislation? Is it policy? Is it commercial incentivization? I mean, how do you sort of make people go out at the right source?
Yeah, so that's a really interesting one. I mean, we saw this in the finance sector in the run-up to what is MiFID II, which is a regulation across Europe. And the driver there really was in order to have a common floor, you can't mandate a particular solution. You can mandate the requirement at the point of use, so the traceability of the timestamp, for example, and what it references to in terms of UTC. And you can actually achieve that via a whole different range of mechanisms, depending on the accuracies of the availability, etc. But in order to demonstrate that, it is about understanding your system, ensuring your receivers are calibrated and monitored. Because if you don't, you could be getting a time which could be ticking at the millisecond or better, but it could be entirely the wrong time. So I could timestamp some data, send it to you, you timestamp it when it arrives, and it could just as well appear to have arrived before it left. But you can't tell that unless you have a reference to compare it to. And time particularly is odd in that sort of frame, because you can have a source of time that's looks perfectly fine, but as soon as you compare it against a reference, it may be completely wrong. And we've seen that in that case as well. So it's really about you could say, the robustness of how it is managed and documented around that uncertainty propagation through the system. That's going to be important in order to achieve synchronization, for example.
No, I found this. I've got to admit, I found this all fascinating and like quite a challenge as well when you consider just how many uses there are and the dependencies on it. So no, that has been very useful to me, and I hope that the rest of the panelists found the same. So thank you very much for your time. As before, I'm sure you're open to contact from any of the attendees.
Absolutely.
If they have any specific questions. So I'd encourage everyone to reach out. And we're now moving towards the longer break, which is notionally lunch break, depending which time zone you're in, as ever. So I'd just like to take this opportunity to thank everyone who's spoken up until now. I'm going to be handing over the chairing and hosting duties to my far more able colleague Andy Rayner for the afternoon session. So thank you very much for allowing me to do this bit and participating. And just before we close for that lunch break, I just encourage everyone, please go to the portal, take a look at the different areas that are on there, some of the exhibitor stands, but also use the opportunity to reach out and try and connect as best we can in this new virtual world. So thank you very much for this first session, and I wish you all a good day and good rest of the conference. So thank you very much.